Alrighty, higher algebra students, back here with Unit 9, Lesson 2, which is quadratic formula again, but now jumping more into the formula after focusing in our last lesson on the radicals and on the discriminant and how many zeros we're going to have. We'll actually get into finding those zeros here today. So just as a reminder, the different sort of scenarios that we could encounter here where we have one real root or one answer, again, that would be when the discriminant is equal to 0. We've got a situation where we've got two real solutions or two real roots, and in this case they could be factored because they both are rational, and that would be with the discriminant being positive. Here's also two real roots, but in this case they'd be irrational, and so we wouldn't necessarily factor here, but again discriminant would be greater than 0. And then finally we have the situation where we have no real roots, where the discriminant is negative, and again it's because it does not cross that x-axis there. So our next step is in how do we solve for these zeros, particularly in the irrational problems where we don't factor. And so obviously we could, if they're rational, we could factor, we could use a calculator or Desmos. But if the irrational, we're going to jump straight to that calculator or a Desmos or the like. We're going to focus on the calculator part in class mainly, being that actually brings us through the process of using the quadratic. So the quadratic here, this idea. So let's look at an example here, and with this example, we've got the quadratic formula here. We've got the calculation for the discriminant again is going to be under that radical, and we're going to be looking at solving here for the zeros, solving with the discriminant to see how many real roots we have, and also what we're looking at here is this calculator suggestion, which is just a reminder that there's a lot of negatives in this formula. You've got a radical, you've got a fraction. So kind of breaking this formula up and making sure that you aren't letting order of operations take advantage of you on the calculator or whatever it may be, probably is helpful to hit enter a few times and kind of break up this formula, and we'll talk about that a little bit here. So first of all, looking at this example, we've got an A value that is equal to 4 right here. We've got a B value that's equal to 2, and we've got a C value that is equal to -5. So for the discriminant, again, the discriminant is B squared minus 4AC. So our B squared on this one would be 2. 2 squared minus 4 times A, which is 4, times C, which is -5. So this would be a 4 minus, and then 4 times 4 is 16. 16 times a -5 is a -80. So we've got 4 plus 80 or 84, which means we do have two real roots on this problem. So what that means is we're going to actually put the values into our equation. So we've got -b, which is a -2, plus or minus the discriminant, which we've already actually found that to be 84, so we're comfortable with that. And then divided by 2 times, 2 times A, which is 2 times, keep hitting the side here, 2 times 4. Okay, so our answers here would be -2 minus the square root of 84 over 8, or -2 plus the square root of 84 over 8. Now we can actually simplify this radical a little bit, so we could make it -2 minus, and this would be root 4 and root 21, so we can just write this as 2 root 21 all over 8, and then -2, sorry, I'll get rid of that, plus 2 root 21 all over 8. So these would be our respective solutions for our zeros, and we could simplify a little bit here. So this is really -1 minus root 21 all over 4, since we've got a -2 over 8 and a -2 over 8. Similarly here, we've got a -2 over 8, so that would be a -1 plus root 21 all over 4. So really all of these answers technically would be correct here, but I'll just put the most reduced and simplified form here. -1 minus root 21 over 4 and -1 plus root 21 over 4. So these would be our two solutions to this quadratic in terms of our two x-intercepts, our two real roots, our two real solutions, or what the x value would be when the y value equaled 0. So with that, again, you technically could write this as -1.3956. That's an approximate answer, but we will leave our answers as real solutions here, not irrational decimals, but values that may have a radical in them as we try to keep our answers exact. Moving to another one here. So the first thing we're going to do here is we're going to subtract the x from both sides because we need this to equal 0. So we're going to have 4x squared minus x minus 3 equals 0 when you subtract that x from both sides. Okay, so that means our a is 4, our b is -1 since this is a -1x, and our c would be a -3 since it's minus 3 at the end there. So for the discriminant of b squared minus 4ac, that would give us -1 squared minus, and then 4 times a, which is 4, times c, which is -3. Well, that is the equivalent of 1 minus, again, -1 squared is 1. So if you're doing this on your calculator, make sure you put the parentheses around the -1 there before you square it. 4 times 4 is 16. 16 times a -3 is a -48. So this would be 1 plus 48, which is 49, which means, again, that there are two real solutions because 49, of course, is greater than 0. And if your discriminant is greater than 0, you have two real solutions. So when we look at now putting our quadratic formula in play here, we would have, and I'll change colors here, we would have a -b, which is a -1 plus or minus, again, because b is -1, so it ends up being a -1 or just a +1. Plus or minus the square root of the discriminant, which again we've already said is 49, so that's nice because that makes it cleaner for us. And then we're going to divide by 2 times a, which is 2 times 4. So as we look at the minus and plus versions of this, again with it being both directions here, this would be 1 minus 7, because the square root of 49 is 7, over 8, and 1 plus 7 over 8. Well, 1 minus 7 is -6, so -6 over 8 is -3/4. So that would be one of our solutions would be -3/4. And the other solution here would be 8 over 8, which is 1. So this one, we had rational solutions because our square root was a perfect square there, or at least the value under the square root or under the radical was a perfect square. So we could take the square root of 49 to get 7, and we have our answers there of -3/4 and 1. Now just a couple others using our calculator here. And so we'll write the full quadratic formula here. Again, -b plus or minus the square root of b squared minus 4ac all over 2a. So as we look at, in this case, a is 3, b is -5, and c is 1. So our formula then would be a -5, that's the negative b, or -b, and since b is -5 here, plus or minus, so we have -5 squared, minus 4 times a, which is 3, times c, which is 1. And then that's all going to be over 2 times 3. So again, as we separate this out, I'll do the minus version and the plus version here. That would give us 5 minus the square root. In this case, that square root would be 25 minus 12, actually, because it's, again, just 4 times 3 times 1, all over 6. And then 5 plus, and I'll just rewrite this as the square root of 13 there, since we already know that it's 25 minus 12 under there. Now, 13 is a prime number, so we can't simplify that radical at all. So our answers then would be 5 minus root 13 over 6 and or 5 plus root 13 over 6. So here would be our two x's for our x-intercepts or for our real solutions here to this quadratic. And again, there were two solutions because we had a positive discriminant. Again, the discriminant this time equaled 13, which of course is greater than 0. Okay, moving on to another example. Again, I'll just write the quadratic formula up here. And in this case, we have an a that's equal to 1, a b that's equal to 7, and a c that's equal to negative 10. So our negative b here would be a negative 7 plus or minus b squared, which is 7 squared, minus 4, a is 1, and c is negative 10, all over 2 times 1. So again, we've got two potentials here. Let's see what we have for the minus and the plus. And so what we end up with is negative 7 minus the square root, and this would be 49 minus, and that would be a negative 40. So that's 49 plus 40, or 89. And that's again all over 2. So this would be negative 7 minus the square root of 89 all over 2. And 89 is also prime. So we can't divide that by anything here to, or can't simplify it, I should say, to simplify the radical. And again, then the other one is negative 7 plus root 89 over 2. And again, these would be our two solutions. And the solutions, again, there's going to be two of them because our discriminant in this case equaled 89, which is that value under the radical. Let's move on to one final example here. So again, we've got our format as we need it here. We've got an a value that's negative 1, a b value that is equal to 1, a c value that is equal to negative 4. So going again with our quadratic, negative b plus or minus the square root of b squared minus 4ac all over 2a. Change color since we're seeing a lot of blue here. So what we'd have then is that x equals negative 1. Again, that b is 1 and the negative is out front. So plus or minus the square root of b squared, which is 1 squared, minus 4 times a times c, all over 2 times a. Okay, so as we look at the two options here, we've got negative 1 minus the square root of 1 minus, now we've got 4 times negative 1 is negative 4. Negative 4 times negative 4 is 16. So this is actually 1 minus 16. So you can see what's happening here is we actually do not have any real solutions. Okay? So what ends up happening here, we'll look at this shortly, is this is negative 1 plus the square root of negative 15 all over negative 2. Okay, and this would have been negative 1 minus the square root of negative 15 all over a negative 2. So this would be these would be our solutions here. But again, these aren't real solutions because we have the square root of a negative value in there. If you were to type that into your calculator, you'd get an error. So what this involves is what are called imaginary numbers, which is where we will go to next so that we can look at this as two imaginary solutions for our quadratic here. So I'll leave it at that for now, but just know that technically these are not real solutions right now. Okay, well, like I said, we'll get into imaginary solutions here next lesson. But for now, we'll leave it at that. So thank you as always for listening. If you have any questions, please ask.